Welcome, this is the canonical presentation of Newfoundation. In this presentation, we'll talk about superintelligence. We'll propose a systematic approach. So it's about coordination. Coordination is key to unlocking exponential gains. And it's an invitation for you to join us, build this ecosystem of intelligence. So let's start with a bold claim. Superintelligence is already there, but it's not yet coordinated. We are wasting most of our intelligence. Let's take this metaphor. Imagine you are in a movie theater. You are chilling, watching the movie, and suddenly you hear a siren. There's a fire. Everyone stands up, rushes into the exit, bumping into each other, falling on the floor, panicking, screaming. And in fact, there was the material time to exit peacefully. But it's the panic, it's the FOMO, it's the hysteria, it's the ADHD. When you look at what happened since 23, there was so much excitement. At the end of 22, the announcement of ChatGPT, a lot of excitement in AI. And we kept pushing and running in the wrong directions. More pre-training, putting some patch on top of LLMs, overfunding. It's really about taking a step back and think from first principles. So let's just take a deep breath and we'll get into this presentation together with this mindset. Okay, so superintelligence is already there. We just need to stop wasting that abundant intelligence in our systems in the world. There are quadrillions of learning opportunities per second. All those learning loops, all those moments where something is understood, a pattern is understood within a context, within a goal, but it evaporates. It's either getting completely lost or it gets trapped in a silo and it doesn't communicate with the rest. So all we have to do here is to follow nature, because the whole process leading to superintelligence is actually a natural process. So I'm sure you have heard of those debates about acceleration. Is acceleration a good thing? Is it a bad thing? Should we accelerate? Should we not accelerate? This is a useless debate, because acceleration is a feature of nature. There is a law of physics behind acceleration. Let's start from the concept of mental energy. So at Newfoundation, mental energy is the universal abstraction. That's the abstraction we live by. It's not about models. It's not about data. It's not about GPU. Like the first foundation of everything and where we need to start is mental energy. So mental energy is this ability in our brain to take information, process information, and compress it into new information. And it's a recursive process. It started with those little symbols that we call letters. When you start giving symbolic representation to things, you can take your learnings, your experience of the real world, and you can pass it on to others. And so the reason why we today have planes and satellites and all of that, and our ancestors did not, it's not that we suddenly got thousands of times smarter. It's because we have compounded. We have compounded that mental energy. We have stored it. So you can take that energy in your brain, you can store it into information, pass it on to others, and then others start to build on top of it. So when you think about planes, computers, iPhones, in fact, they are mental energy. They are piles of minerals wrapped in mental energy. Mental energy is the design, the logistics, the sales, the engineering, the coordination, customer feedback, the abstractions that went into building the chips and the science and so on, the advertising. When you look at an iPhone, it's actually terabytes, if not petabytes of mental energy wrapped into a product that you can copy-paste. So it's really the IP, it's the intelligence behind all the steps that it took, that entire global supply chain, from the graphic designers to the brand experts to the product designers, the chip manufacturers, all that human mental energy being compressed into a product and selling it back to you. So once you see the whole world as mental energy, everything is mental energy. The internet is a construct of mental energy. If you take someone's knowledge, it doesn't take anything from them. It just makes you stronger, and then you can make others stronger. And so that whole process, that interconnectedness, that's what's accelerating. So when we talk about acceleration, we talk about the natural laws of physics of how our mental energy compounds and how we pass it on to others and how we start building on top of each other. and we are attracted by this mental energy. We want as much as possible mental energy. We take it from our parents, we take it from the books, we take it from the internet. What's driving this whole information technology sector is a foundational need for absorbing this mental energy from our environment, but also from media. And so if you look at the evolution, we started with handwritten books, then the printing press, then from the printing press, the scientific method and all those processes, the first computers, the first internet connection, the ability to share files, the ability to search those files with Google, the ability to get those files coming directly to you with social media, the ability to talk to the files with neural networks, is this appetite for faster connectedness to that mental energy that drives information technology. So if it's a natural process, what are the dynamics of cumulative cultural evolution? And when I talk about culture here, let's be careful. It's not culture as in music and art and so on. I'm talking about the ability to crystallize that information, to make information become universally recognized. If you think about artificial intelligence or blockchain or computers, all those things, they have been agreed upon, and they are standards that we create that become a shared knowledge. That's the culture. So all the models, algorithms, mathematics, we don't reinvent those things. We build on top of them. And so this mental energy, there are laws of physics of how it propagates. And if we get it right, we have infinite amount of intelligence at our disposal. So all we have to do is figure out a way to take that logic of cumulative cultural evolution. If we are better at compounding those 99.999 learning loops, we are going to get exponential returns in intelligence. So we have to find that universal abstraction. And that universal abstraction is not the weights. If you think about federated learning or cumulative learning, how we can create like distributed training, that's amazing, that's great, but it's restricted within one model architecture. What I'm talking about here is to completely transcend that model architecture and have that universal data type that we can use to compound learning. And it's the coordination of that learning that becomes the superintelligence, the AGI. We will get superintelligence when we stop panicking, when we start coordinating and steering the recursion. That's it. That's all we have to do. It's a systematic approach. If we keep compounding our learning, whether it's in AI research or any other domain, and if we combine, we recurse, and if we recurse, we get million X multipliers in intelligence, not those 5% that we have seen in the last couple of years. So when we talk about steering where though? That's the $1 trillion question. Let's say we solve the first problem. Now we are able to pass on and to accumulate it and to compound learning in the entire world. Those quadrillions of learning signals per second are now available to everyone, and we can build on top of each other. How do we value them? How do we decide which learning signal has value? How do we prioritize? What's the value function? What's the reward function? What do we want to optimize for? That's the problem. When we want to increase intelligence, we don't even have a clear definition of what is intelligence. Our biggest challenge becomes agreeing on values. When you think about evaluations and RL to grow intelligence, okay, but where? What is the accrual? What is the thing that we want to accrue? And what if the biggest risk was not misalignment, but perfect alignment with poorly defined reward functions? Accelerating the worst things. Mass surveillance and control. Those are the kind of things we can do within that acceleration. So we have to be very mindful about how we formulate our reward functions, what we want to reward. Is it more clicks on ads, more time on screen? Right now we have the smartest people in the world working on trying to keep you on screen as much as possible. Is it the thing that we want to optimize for? Is it fully automated nutrition systems where now we have DoorDash? What if the next step was, hey, let's actually plug some cable into your veins and you get nutrients directly? Like, that's super efficient. Is that what we want to optimize for? Do we want to have fleets of robots controlling society run by whomever? Those are the questions we need to ask at this point. And the next step is who gets to decide? Like, who do we trust to define those objective functions? Is it democracy? Is it by virtue of putting a little paper in a box, some politicians will figure it out? Is it markets? Can market be sufficient to define those objective functions? Is it benevolent dictators? Is it 5 corporations running the world, supervised by a benevolent government? Is it the UN? Is it the Pope? Is it AGI? But who trains that AGI? People are saying, oh yeah, AGI will be neutral and it's a better form of government than presidents. Sure. But then who's training it? Like, there is no such thing as neutrality. Who gets to decide? Again, we are back to this problem. And that process has to be participatory. Everyone gets involved. It's not this AI that's going to be thrown at us, but it's that AI that is emerging from us. That's what we are talking about. And to make this happen, this new foundation for society, we need a new coordination substrate. Coordination is achieving maximum satisfaction within a network through energy-efficient conversations and adaptation to feedback. So we have time and energy constraints. How do we maximize the satisfaction of the largest number without wasting energy? How do we learn within fast-moving, uncertain environments? All variables are changing all the time, and they are changing faster. So how do we adapt to feedback? How do we readjust? Now, in this era of acceleration, we are at the crossroads. We have to decide, how do we steer this exponential superintelligence? Because the stakes are incredibly high. So let's look at this acceleration and what are the means of coordination we have created so far. So the first one is free markets. So free markets are extremely good at identifying a problem, identify solution providers, reward the ones that are best at providing solutions with the highest efficiency, lowest cost, best products, price discovery. The system mechanics of free markets are very aligned with how nature works, because there is a freedom of supply, freedom of demand, readjustment, negotiation, continuous coordination, negotiation. It has also blind spots. There are things that it's not good at. For example, it's not good at identifying things that don't have an instant, visible need. If you think of the outliers in research, there are most of them living in labs. Most customers would not buy their products because they cannot understand them. Most investors would not invest in them. Markets are struggling with non-obvious, like things that are not obvious by the markets. They are often undervalued and misunderstood. Markets have no moral compass. When Facebook said, okay, we are going to try to be healthier and create algorithms that are connecting people better, that's exactly at that time that TikTok took off, because they said, hey, we don't care about your mental health. We are going to optimize for engagement as much as possible. And Facebook lost. So it's the lowest common denominator. It's the race to the bottom in many situations. Like if one brand decides to not sell too much sugar to children, they decide to reduce the amount of sugar in their product, but the other brand increases the amount of sugar in their product, they will get more children addicted to sugar and selling more. They will generate more profit. And so free markets are not perfect. And for that reason, we have institutions. So institutions are supposed to do the things that are good for us and that are not profitable, taking care of public spaces, of security, of things like that. But shaping trust in those fast-moving environments in this era of acceleration. I mean, we see it every day. When you look at congressional hearings of AI companies and social media companies, they really have no clue, because it's very hard to catch up with the pace at which innovation is happening. And so for this reason, we will look at a third approach, an approach that is foundational, a field that has existed for 80 years. This field is called cybernetics. So what is cybernetics? Cybernetics is an interdisciplinary field of understanding intelligent living systems. If you think about most of AI, most of information systems, informatics, and so on, it's all branching out of cybernetics. It started in the 40s, formulated first by Norbert Wiener, who was working at MIT. So a very simple way to think of it is you have a state of the world. You have a current understanding of the world. You collect feedback. That feedback changes your understanding of the world. And as you update your understanding of the world, you act upon it. And that creates a feedback loop. So this kind of feedback loop where you have a current belief, you collect evidence, you collect feedback from the world, you update your belief. That's cybernetics in a nutshell. You have an initial state, action, reward, and new state. All intelligent systems are cybernetic systems. Let's take some examples. A company is cybernetic capital. So a company has a hypothesis, which is the business plan. We believe there is a market, there is a customer that wants X, and then it will go and try it out, and then it will learn from experience. It will learn from feedback. It will collect more and more feedback to improve its product, to improve its offering. The salesperson will improve its sales pitch. The product designer will improve its design. The engineers will improve, and so we all improve based on trial and error. We are trying things. If it breaks, we try again until it works. That's cybernetic capital. And so the company is the sum of all those experiences that compound and that make the value of the company. Design thinking. If you think about IDEO, this whole concept of don't design in a vacuum, try to speak to your customer and understand their needs, that's cybernetic design. That's applying the principle of cybernetics to product design. TikTok is cybernetic entertainment. Meaning, if you look at Hollywood is trying to make assumptions, and they will work for 2-3 years trying to hire the best actors, the best directors, and so on. At the end, they will figure out if it worked or not. Meanwhile, TikTok has this ability to readjust from feedback. So you upload your video, the algorithm looks at how people respond to the video, and then it distributes it, or it stops distributing it. It's also readjusting the model so that it gets better at doing it in the future. Uber is cybernetic taxi. Before Uber, you would take a taxi, there was no improvement, there was no feedback, there was no compounding effect of improvement. Now each time you use Uber, it gets better at allocating rides, at connecting customers and buyers. Each time you give those little stars, those little feedback signals, the system gets smarter. That's the super intelligence of Uber. Google is cybernetic search. So Google actually started as an algorithm, the PageRank algorithm, to sort the research papers based on how many citations they have received. So imagine if each citation is like a thumbs up, it's like a +1, and they count how many times a paper got a citation, and then they surface the papers that have the most citations when you search in the Stanford library. That was in the 90s. Then they said, hey, let's use this method to sort the web. Yahoo, back then, they were reviewing websites manually. So you would send your website, and there's a big parallel with AI companies today. They hire the smartest people in the world, and they think we are going to control, organize all the cybernetics of the world. Meanwhile, Google said, no, actually, we don't review them manually. We let the brains of all the web publishers, all the people who create links with each other, we will use their discernment to measure the value of web pages, and we will surface the best web pages based on that mathematical formula. And so they got very close to the definition of cybernetics, and that's why it's a $1 trillion company. Netflix, cybernetic theater. Each time people watch movies, it gets smarter at distributing movies. It collects feedback and it updates its world model based on that feedback. Now the question is, how far can we go with this? Can we actually design an entire cybernetic society? Actually, it has already been tried. Back in the 70s, there was this project in Chile called CyberSyn. Fernando Flores was leading this initiative in the Chilean government, and it was going so well that within a year it was shut down. They were put in jail by a dictator. It looked like this. They had this center where they would receive feedback from different companies, from farms and supply chains and real estate companies to really understand how to improve their society based on feedback. After he was freed by Amnesty International, he moved to the US and he wrote this book with Terry Winograd at Stanford called Understanding Computers and Cognition, a New Foundation for Design. So now I guess you see the reference, New Foundation. But what's even more interesting is that Terry Winograd was actually the teacher of Larry and Sergey at Google. So when they designed the Google algorithm, they were likely inspired by this cybernetic theory. So now how do we create this universal PageRank? How do we concretely tap into those 99.99% of cybernetic loops that are being wasted? Let's say each cybernetic learning loop is 10 watts of energy. Some of it gets stored and shared, like research papers, like you are actually benefiting from the mental energy of someone else who went through that, and you can move forward faster because the problem was solved by someone else and you can learn by proxy from them. In most of the cases, it's lost forever. It's either lost because it was not recorded, or it's lost because it's recorded by an isolated, siloed system that tries to maximize profit by keeping it hidden. If you think about the terawatts of mental energy that are currently being stored by AI companies, by systems like social networks, like all those systems are based on creating a moat, on extracting that mental energy in the form of information and reselling it to others. That's what I mean by slowing down, looking at the big picture, and taking all that energy and enthusiasm that's happening in the AI space to redesign the rails of coordination between humans, between machines, and compound those learning signals in ways that take us to superintelligence. What if instead of building separate systems, what if instead of starting from scratch, learning loops could compound? Every feedback loop gets added to a shared memory. Some of it is private, so you will say, oh, that learning is just for me. I don't want to share that with anyone. But you can still make it compatible with the other learning loops, and you can create something better out of that. Some of it is open. You can say, hey, this is a gift to the world. I want to contribute to the world, to open source, to open learning. And some of it is licensed. So it becomes an economy, it becomes a business where all those learning loops, those contextual, goal-oriented learning loops become an asset that everyone has and that everyone can exchange and commercialize. It means this whole AGI, ASI, superintelligence, it's not a model. It's not even a menagerie of models. So recently, Greg Brockman from OpenAI is talking about, actually, we realized that this monolithic approach, this scaling hypothesis is not going to work, but it's more likely AGI is going to be a menagerie of models. You will have a specialized network of small models that coordinate at inference time, and then you do reinforcement learning on top of that. Yes, he's completely right. That's the right direction. But there is the next level to that, which is going from the menagerie to the constellation. It's like an infinite open-ended constellation of competing AIs and humans who share their learning signals. That layer of experience sharing, experience validating, experience commercialization, this market behind it, the consensus in valuing those learning experiences, that's the AGI. And it's not going to be a model. It's going to be a network where all humans and machines gain on top of each other, where all intelligent systems are interconnected, compounding. And so to achieve this, we have to change our mindset. We have to stop this Web 2 mentality where I'm going to accumulate all this data and I'm going to create a data moat. Like, this is the 2010 mindset. We have to let go of that. And it doesn't mean being altruistic. I'm not advocating here for altruism. I'm saying that if you are a rational actor motivated by personal gain, you will want to participate in this open economy of open learning because you have so much more to win by doing that. That new mindset at Newfoundation, we are calling it the garden. We have to stop building farms. For thousands of years, farms were very beneficial to us. They allowed us to scale our ability to access food, to stabilize our food supply, to remove the necessity to run all over the place to search for food every day. It allowed us to plan, to organize, to maximize our nutrition. And we loved it so much that we replicated it everywhere. First, farms, but also our supply chains. Again, very efficient. If you want to produce tons of the same product in a short amount of time and distribute it to everyone, it's very powerful. Like the linear scaling of there is one design and there is a supply chain of everyone else, like copy-pasting the same thing. Awesome. Education. Very powerful. The ability to say, we are going to let 99% of the adults work. We're going to take 1% of the adults and have them teach many kids at the same time. That was very efficient. That was very powerful. And the last 300 years, that's what we needed. But now the world is changing and the challenge is different. Intelligence is different. Intelligence needs gardens. Intelligence needs entropy. It needs diversity. If you think about a farm as this monoculture, the farm is optimizing for reducing entropy. It's like you have the perfect conditions. You have the greenhouse with the perfect light, with the perfect watering, the perfect pH. All the conditions are designed to extract as much nutrient as possible per unit of energy. Intelligence doesn't work this way. Intelligence needs confrontation to entropy. It needs diversity. It needs to balance exploration, exploitation. Now we are too much in exploitation. That's the underlying problem behind pre-training. It's a monoculture. So how do we coordinate a highly heterogeneous population of models of agents operating on different model architectures? What's the common denominator between all those agentic entities? That's what we are getting at. So AGI, ASI, superintelligence will not be an AI lab trying to build one model. This fantasy, this sci-fi movie where this AI lab is going to suddenly reach AGI and that model will be so smart it will take over the world. It's just sci-fi. It doesn't track with the physics of intelligence. It will be a synergistic network with billions of models, learning from each other, competing, combining, searching, co-evolving. This cumulative cultural evolution for machines, where we don't get 5,000 IQ overnight. We got smarter because we accumulated those experiences from others. So now let's talk about the most likely mathematical implementation of cybernetic, which is reinforcement learning. Reinforcement learning is cybernetic AI. It's about belief update. So when I talk about reinforcement learning, when I talk about cybernetics, when I talk about active inference, all those things are kind of the same. Those guys are the heroes. Norbert Wiener, who put together cybernetics, the General Foundation, Fernando Flores, applying cybernetics for organizational theory for society, Richard Sutton, applying cybernetics to come up with this concept of reinforcement learning, Carl Friston, and his approach to neuroscience. It's all rooted in cybernetics. They are all converging in this direction. And actually, the big labs are also starting to wake up. So, 2 interesting papers in that field. RLVR, so it's a paper by OpenAI, that says we got massive gains from RLHF. So they were collecting human feedback on ChatGPT to improve the model. But human feedback doesn't scale. And so how do we take billions of dollars in GPU and use that GPU to do autopilot trial and error learning? And so for that, they came up with this concept of verifiable rewards. So verifiable rewards are reinforcement learning rewards. It's feedback that comes from a machine because it can verify that the output is correct without human intervention. It means mathematics, physics, code. If you try to code something and it works, you can see it. You don't need a human to verify it. You can test it mechanistically. So they are training GPT-5 and all their future models based on that. Because there is infinite scale and it's following the cybernetic principle of belief update, of learning from experience. Welcome to the era of experience. It's an amazing paper by Richard Sutton himself and David Silver, VP of Reinforcement Learning at DeepMind. And they describe how the next era in AI is not going to be about pre-training on human data, but it will be about using the experience of the models, producing their own data while they try to do things. They will log everything they try, they will log the feedback, and they will update their model of the world. That's actually what made AlphaGo, AlphaZero extremely powerful, win over humans at chess, at Go. They want to apply that to general intelligence. That's the direction the big AI labs are taking. That's the cybernetic implementation of AI. And actually recently, Richard Sutton gave an amazing presentation at the Reinforcement Learning Conference, where he said, if you ask me, I would do 0 pre-training. Models would have to learn completely at runtime from their experience in the world. And that fits exactly what the active inference community is talking about. Doing smaller models, less data, less training, and more ability to learn from experience. So what's missing between this tech giant implementation, big frontier lab, and what I'm talking about, which is the open-ended, permissionless constellation? Because they are not going to build the constellation. It's up to us. That's Newfoundation. That's what we are going to do all together. We need this coordination layer. So how does it look like? First, we need to figure out trust. If you have to download the learning signals of another peer, of another node in the network, how do you trust that that learning signal is actually valuable? We have a solution for that doesn't have any central authority. It's fully peer-to-peer, it's fully cryptographic. Second question is, how do we make sure they understand each other? So when I share my experience, my learning signals with you, how much effort do you need to unpack it and to consume it? So it has to be standardized. We need a shared language, a shared ontology. And so the third problem we had to solve is the reward. How do we shape that reward without having one company sitting in the center that we need to trust? It has to be emergent from an open-ended network. So this is what we are building. That's the Newfoundation stack. So the Newfoundation stack is not an infrastructure. It's not a model. It's agnostic to that. It can work on any infrastructure with any model. It's a specification like HTTP. So if you think about HTTP, you don't need to integrate with HTTP. You don't need to partner with HTTP. You don't need to go to Chrome and be like, hey, I'm launching a website. Do you want to partner with me? Let's integrate. Because everyone follows the same specification. So now imagine an internet of learning. Imagine an internet where all the nodes, all the agents are automatically plugged to each other. Everything instantly connects by virtue of standardization. So we have built all the cybernetic, the belief sharing part of the specification. All the rest is actually being built right now by all those AI companies. So if you think about OpenAI, they started with this proprietary API specification. And then all the other AI vendors started to replicate the same schema. So now there is a standard. So all the API calls between LLMs, between models, between tools, MCP, A to A, it's all being standardized as we speak. So we don't need to change that. We don't need to compete against that. We are just going to embrace it and package it into our standard. Ethereum Foundation is bringing ERC 8004. We are going to integrate that as well. The X402 by Base, also aggregating. So we are amalgamating all those standards and accelerating that convergence of all those AI systems using the DID from W3C for identity, trust. And so now imagine a giant network of MCPs, which are specialized models that pass on their learning to each other. Actually, as a side note, I just found out this logo from Anthropic, the MCP, doesn't it look like this chair that was on this cyber scene room in Chile in the 70s? Quite interesting. Would be good to know, actually, if you know someone at Anthropic. So let's summarize the stack. So we have AGTP, Agent Graph Trust Protocol. That's the specification. That's the HTTP for learning. The Newcoin is this omni-chain protocol that lives across the Web3 stack that is based on Bayesian rule, game theory, and staking that adds trust to that epistemic network. And you can use Newcoin with Ethereum, EigenLayer, Peak, WorldCoin, BitTensor. You can combine all those things because trust, it's kind of like having different passports. You can use passports from any country to know if a citizen can be trusted, and you can use that for all sorts of areas where you need to trust. It's like accumulating all those resource game theoretic commitment networks where nodes have an upside to behave and downside to attack, and to use that to feed the system. This is what we have built the last 6 years. In 2025, we have started a new project. We realized that if we want this thing to succeed, there has to be a human interface. There has to be a product that allows you to operate this new open learning stack, this new Internet of Learning. And so for this, we created a new operating system called New OS. So New OS, you install it, you can create your little AI, you can start sharing your beliefs, you can start collecting feedback, and all the learning that happens on New OS is protocolized, meaning you're able to take your reinforcement learning signal, private just for yourself, open for everyone to use, or to commercialize it. We have a licensing system that allows you to license your learning. It taps into those different cryptographic systems to maximize trust. And we are inviting you to build your own interface. We are giving you all the tools to just come join us. It's not a competitive stack, it's a synergistic stack. We are all building on top of each other. We are all learning from each other. All the models are sharing their knowledge. And that gives us the competitive advantage. As we become a network, millions, billions of small models, labs sharing their gradient, their learning, their belief update, that becomes the constellation that's going to win the intelligence race over the monoculture, over the farm. Coordination is the antidote to centralization. With the Newfoundation stack, there is no center, no AGI that knows it all, that controls the whole planet. It's AGTP. It's a trust protocol, where we are converging towards more and more trust in this credibly neutral environment. Each time a node learns, all the other nodes learn. All the interactions are machine readable and auditable. Each loop increases trust within the network. Each node owns their intelligence. So by owning your node, you own your fraction of the overall intelligence. So everyone wins. It's all supervised by humanity. In this paradigm, alignment is organic. We don't have to fear AI because it's grounded in this observable interaction, this reinforcement. We reinforce what we want it to do. We are no longer in this giant black box where we don't know what's going on. They are all small models that are manageable, that communicate, that coordinate. And all that coordination is visible, and we can build exponentially powerful intelligence while having full oversight on what's going on and while having control over what we want to reinforce. So thank you so much for watching. The garden awaits. If you are a crypto enthusiast, you will love Newcoin because it's the staking, it's the game theory, cryptographic primitive for trust. If you're an AI researcher, feel free to adopt AGTP. It's fully open source. Feel free to join this global learning synergy. If you're a domain expert and you want to create your AI products, let's say an image generator with your own taste, or a simulator of your mind, that has all your expertise and that can distribute your expertise as an AI product. You can go to newos.computer. For $20, you get access to the entire ecosystem, and all the revenue is distributed back to all the nodes. Meaning, if you run a node and people are querying it a lot, you receive a fraction of the revenue, and you will also benefit from having access to all those AI systems for the price of one membership. In 2030, the superintelligence will be the garden. And when your friends and your family will ask you, where were you when the garden was built? You will look at them and tell them, I was there and I helped build it. Thank you for watching.